Hey everybody, my name is Mel Strong and I'm one of the educators at the Bradbury Science Museum. This video is going to introduce you to the hobby of cloud watching. Cloud watching is something that you can do for free. You can do it almost every day outside, and if you're stuck inside, you can do it through the windows. If you live in New Mexico, you happen to live in one of the best places in the country for viewing clouds. Now, what we're going to learn here is how to identify and name clouds, and in order to do that, we need to know two things about the cloud. We need to know its shape, and we need to know its height above the ground. So for shapes, there are three general shapes that all clouds should fit into: cumuliform, stratiform, and cirriform. I'll show you examples of those in a second. And then there's three heights that all clouds should fall into, either low, middle, or high. So given those variables, there are 10 basic cloud types that we can come up with from this system. And the system that we're talking about was first published in 1802 by Luke Howard. He was a pharmacist, he lived in England, and he decided that the world needed a cloud classification system, so he made one up. It's not great, but it is still in use today. And here's some of the pictures of paintings that he made back in the 1800s. So let's talk about the different shapes. And so first, the cumuliform clouds are the ones that are puffy. Sometimes we call these heap clouds, like it's a big pile of a cloud. You can see the edges of cumuliform clouds, and they can be different shapes. They can be long, they can be tall, they can be nearly circular, but what they all have in common is they sort of have this cauliflower look, or like cotton. They're puffy clouds. Those are cumuliforms. Then stratiform clouds are far more boring. They are more like a solid blanket across the sky. You can't really see the edge. They typically form, a solid gray sky, something like that. Those are stratiform. And then cirriform have all kinds of interesting shapes. They're kind of these wispy, curly, hairy clouds that are high up in the atmosphere. Okay, so those are our three possible shapes. Now for the three possible heights. And to understand the meaning of low, middle, and high, we're going to think a little bit first about what the air above the ground is like. So I want you to imagine that you're in a balloon and you're going to rise up from the surface up into the atmosphere. And as you go up, you're taking the temperature, right? And you're recording it. What would you notice? So what you would notice right away is that as you got up into the sky, you would notice it gets colder. Now let's imagine that you took these temperatures and you put them on a graph, right? So I'm going to make a graph. So the x-axis of my graph is temperature. It gets warmer to the right. Height is on the y-axis. So if I start to float up in a balloon and I graphed what I'm feeling, I would notice that it's the warmest near the surface, and it gets colder, 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 and until I get way up here, maybe 10 kilometers or so, and then something weird happens. It starts to get warmer again. Now the reason it gets warmer again, we don't have time to get into that, but it has to do with the ozone layer. But this little corner right here, the transition from when it gets colder with height to where it gets warmer with height, that forms a natural boundary between two layers in the atmosphere. All the air below that point is called the troposphere, and all the air above that point is called the stratosphere. It turns out that all the clouds we see are in the troposphere. All the weather happens in the troposphere. Not much happens in the stratosphere. So when we talk about low, middle, and high clouds, what we're talking about is where in here do the clouds occur. Now, this actual height up here, it depends on where you live. It depends on the time of year. On average, it's about 11 kilometers high. For New Mexico in the summer, it's going to be quite a bit higher than that, maybe 15 to 20 kilometers high. But high, middle, and low depends on where you are in this layer. Okay, a low cloud is near the bottom. Doesn't mean it's at the actual surface. It's not touching the ground. But low clouds are down here, middle clouds, and then high clouds are up near the top of the troposphere. So if we have a cloud that's in the upper part of the troposphere, we call it a high cloud, it is going to start with the prefix cirro. If we have a cloud that's sort of in the middle, it's going to start with the prefix alto. If we have a cloud that's down low, it does not have a prefix at all. Okay, so let's do an example. If I have a puffy cloud, a cumuliform cloud, and it's down low, I'm going to call that cumulus. If I then move to the middle part of the atmosphere, the troposphere, I'm going to add the prefix alto to it. So it's an altocumulus. And they're going to look smaller because they're higher up. And then if I move them all the way to the top of the troposphere, I'm going to call them serocumulus. And they're going to be smaller still. So this is sort of the naming system. Now if we have stratiform clouds, and I have a thin layer up at the top of the troposphere, that's cirrostratus. If it's thicker and extends down to the middle part of the troposphere, that's altostratus. And if it extends all the way down near the ground, doesn't necessarily have to touch the ground, but if it's down pretty low, that's stratus. Okay, so we're going to look at some examples of these. So we're going to start out with the cumuliform clouds, and we're going to look at some cumulus clouds first. So cumulus clouds are probably the most common cloud that you have seen. And if you're laying on your back looking for shapes in the clouds, you notice they're kind of slowly changing. Those are usually cumulus clouds. Now cumulus clouds, they're changing fast enough that as you lie on your back, you can actually see them move. But I'm showing you some time-lapse photography here. And I want to illustrate the point that cumulus clouds are constantly changing, and they're constantly either being born or they're dying. So for example, this one here is dying, this one here is being born. And you'll notice that the clouds in this time lapse are wider than they are tall, okay? But that doesn't have to be the case. Here's a cloud that is taller than it is wide. Now what's happening here is that there are plumes of warm air that are rising up, creating new clouds to form. So a cumulus cloud will grow vertically as long as a plume of warm air continues to rise. So for example, if you go out in the morning, you might see something that looks like this. Here's little baby cumulus clouds that are starting to form. There's warm air rising up from this mountain, and you'll see that they're born for a little bit, then they live for a little while, and then they die out. Now if I go a couple hours later, I'll notice that the warm plumes of air rising up, they're warmer now because it's a couple hours later, and they can rise farther. So what happens is you start to get taller and taller cumulus clouds as the day progresses, if the conditions are right. Now, in New Mexico, our cumulus clouds often have flat bottoms, and that's true as long as the cloud is growing. Here's one that's starting to fall apart. You're seeing this cloud is starting to die, and the bottom is becoming less flat. Okay, so here's another one over here. This part is pretty flat. This part of the cloud is growing. This part of the cloud is dying, and you'll see that the bottom of the cloud starts to fall apart as well. So in New Mexico, we have a lot of clouds that are flat bottomed, and that is just due to the fact that air rises up into the bottom of the cloud. Beginning of The Simpsons, cumulus clouds. That one kind of has a flat bottom, not quite though. So now we're going to go further up into the atmosphere and look at altocumulus clouds. Altocumulus clouds are smaller. They look smaller to us because the clouds themselves are physically smaller and they're farther away from us. They're thinner than cumulus clouds, and one of the things that you'll notice is they typically form patterns. It's rare to find isolated altocumulus clouds, and when you do find them, you'll notice here they tend to form almost kind of like a patchwork pattern. So for example, if I look here, I'll see that there's kind of alternating cloud and a little space between the cloud. So this is common with altocumulus. Here are altocumulus that are so close to each other they're touching. So it's like a blanket of altocumulus clouds, but you can tell they're puffy. So these are altocumulus. Often they will form patterns such as these ridges. What's happening here is the altocumulus are lining up in rows, and this is a common thing that altocumulus will do. So again, here you can see them lining up in rows, right? So that's common. Also over here, this is some lower cumulus. So in this one movie, we've got some cumulus over here. We have altocumulus over here. So you can kind of see the two different heights in the same movie here. Here's another example of the altocumulus forming rows like this. And we call this altocumulus undulatus. Undulatus means there are these undulating rows of clouds. All right, now we're going to go further up. We're going to go further up to the serocumulus. So now the clouds are going to be even smaller and thinner. They're so thin and they're almost transparent sometimes. So here's some really high, thin serocumulus clouds. Little puffy spots is all they look like. Here's some more. These are all serocumulus. You'll notice that some of them are starting to form little ridges, so that can happen. Every one of these little specks you see is a serocumulus cloud. And so all the little specks together will form different patterns that change over time. They also do that undulatus pattern. The ridges, just like the altocumulus do, that's also common. So, here's a challenge then. How do you tell serocumulus from altocumulus? They're both puffy, they're both kind of small. Well, the altocumulus should be larger, but that's not always true. But I want you to compare these two pictures. Now, because the altocumulus are lower and they're a little bit thicker, they tend to have more of a three-dimensional appearance to them. See, if you were an artist and you had to paint this, there would be some shading in here. Serocumulus often look two-dimensional. They just look like white spots. Now, this is not a hard and fast rule because it depends, like at sunset and sunrise, you'll see more shading on the clouds and that kind of thing. But in general, use this as a rule if you're trying to tell the difference between altocumulus and serocumulus. Altocumulus will have this three-dimension shading texture. Serocumulus will just kind of look like flat spots. So far we have talked about cumuliform clouds that are either low, middle, or high. There's another type of cumuliform cloud that actually starts low and grows high. And this type of cloud grows because warm air is rising up into it. So here's a cumulus cloud that's growing. And if the conditions are right, it will continue to grow vertically into colder and colder air until it develops ice crystals near the top of the cloud. Those ice crystals will fall down into the cloud, and as they fall down, they'll grow and they'll become larger until they look like snowflakes. Those snowflakes then fall down into the warmer part of the cloud and then out the bottom, and somewhere down here they're going to melt usually and turn into rain. So we end up with a puffy cloud that's raining, and that's called cumulonimbus. Now, the nimbus means precipitation, and by precipitation it could be rain, it could be snow, it could be hail, it could be sleet, but anytime you have a puffy cloud that's producing precipitation, we're going to call it cumulonimbus. Commonly these are called thunderstorms, but it turns out you don't actually have to have thunder to have a cumulonimbus. So let's watch one of these being born. Here's a cumulus cloud, flat bottom, warm air is rising up into it. If you watch near the top of this cloud, you'll notice that it starts to look kind of fuzzy on the edges. That's what ice looks like. The ice is falling down inside the bottom of the cloud, into the cloud, and look what's coming out the bottom. We have these streaks. This is the precipitation that's coming out the bottom of this cloud. Here's all the ice that's forming at the top of it, and we continue to see streaks coming out the bottom. We're making precipitation. So we saw the transition from a cumulus cloud to a cumulonimbus. Now, let's watch this one grow. It's growing vertically, but notice right here, it looks like the cloud is getting stuck. Instead of growing vertically, the cloud is moving sideways out the sides here. This is a common thing that cumulonimbus clouds do. There's a limit as to how tall they can grow. And that limit is determined by the structure of the atmosphere. So if I go back, remember going up in a balloon, we said it gets colder, 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 colder as you go up, and then it turns around and it gets warmer again. Well, if I have a plume of warm air rising from the surface, it will continue to rise, but when it reaches this stratosphere, it can't go any higher because the stratosphere is warm. You can't make warm air rise in other warm air. So what happens is the cumulonimbus cloud grows horizontally up here, and this forms kind of a funny hat. And we call that funny hat an anvil. And the anvil will continue to grow as long as the cumulonimbus is itself growing. So the anvil is an easy way to tell if you have a cumulonimbus cloud from a distance. Okay, so here we have a cumulonimbus, and at the top, this is the anvil forming. and all this is ice. So we see ice coming out the anvil, venting out the top here as the anvil is expanding outwards. Here's one from a distance. Now, is it raining? Well, I can't see if there's rain or not, but I see the anvil, and the anvil tells me that I have a cumulonimbus. So yes, it is raining down here below somewhere. You see the fuzz? That fuzz, that's all of the ice at the top of the cloud. Here's an anvil forming. So this is all ice up here, and this anvil, you can see it's forming, it's moving out sideways. Again, I can't tell if it's raining down here, but because I see this anvil and the fuzzy ice of the anvil, I know it's probably raining at the surface. Here's some anvils far away again. This big structure and this one too, those are two anvils from two cumulonimbus clouds off in the distance. Sometimes you can't see the top of the cloud. So here I know it's cumulonimbus because I can see the rain. In a cumulonimbus, you can usually tell the beginning and the end of the rain. It's a pretty small column of precipitation. So that's a cumulonimbus. Anytime you see streaks like that, you have a cumulonimbus cloud. We have one more type of cumuliform cloud left. If I have a single low puffy cloud, I would call that a cumulus. If I have so many cumulus clouds that they end up touching each other, it gets its own name. It's called stratocumulus. Now, we don't get a lot of stratocumulus in New Mexico, but here's some close examples. Here you notice that everything in the movie here is a puffy cloud, but there's so many of them that they're almost touching each other, and we can barely see the sky. That's pretty close to what stratocumulus looks like. Here's a better example. So everything we see here is a puffy cloud. We really can't see any blue sky here. If I pulled out one of these by itself, we would call it a cumulus, but all together, this is called stratocumulus. Now, stratocumulus are rare in New Mexico, but it turns out that they're the most common cloud on Earth because they typically occur over the oceans. Here's a picture I took in Houston. This is typically what stratocumulus looks like. Low clouds, not so much a flat bottom, kind of a droopy bottom on these clouds, can't really see the sky. Here's a satellite picture. This is California, there's the Bay Area here, and all of this area, all this is all stratocumulus clouds out here over the ocean. This is not my picture, but this is kind of what it looks like. So droopy, not really flat bottom, thick puffy clouds. Can't really see the sky, but you can tell the little breaks between them. That's typical stratocumulus. If you ever take an airline flight over the ocean, you often see this. This is what the top of stratocumulus looks like. So it's a big blanket of puffy clouds. And sometimes you'll fly over the ocean, you'll see this just for hours and hours, stratocumulus. So now we're going to move on to the stratiform clouds, which are much more boring to look at. Let's start with stratus. Stratus are the thickest of the stratiform clouds, and they're so thick that we actually can't tell where the sun is. So the sun, it turns out, is right up in here, but you can't tell that from this. The cloud is too thick. So stratus clouds are pretty boring, just a solid gray sky, can't really see the edge of the cloud, can't tell where the sun is. Okay, stratus clouds. Now, if that thick stratus cloud is raining, we're going to add the prefix nimbo to it, and that's a thick cloud that's raining, a thick stratus cloud that's raining, nimbostratus. We don't get a lot of nimbostratus in New Mexico. Typically, when you have a nimbostratus, it's raining all day long. Okay, that doesn't happen so much in our part of the world. But here's what nimbostratus looks like. We got a solid gray sky, and it's either raining or snowing. Either one, it's nimbostratus. Another example, here you can see there's a little bit of texture in the sky. Okay, that's common, but it's still gray as far as the eye can see and raining, kind of a constant, steady, slow rate of rain throughout the day. That's nimbostratus. Another example, solid gray sky in this case. So now we're going to move up to the middle of the atmosphere with our stratiform cloud to altostratus. So this cloud is about maybe half as thick as the stratus cloud. And because of that, the sun actually peeks through and it looks like a fuzzy ball. So here's an example of some altostratus cloud, and you can see some texture, right? That's common. But the key is the sun is going to look like a fuzzy ball. You can tell where the sun is, but you can't see it very well. So that's a good way to tell if you have an altostratus cloud. Now when we go all the way up to the top of the troposphere and we have a little thin layer of cloud that's cirrostratus, we're so high up that that is a blanket of tiny ice crystals. And before I show you what that cloud is, I'm going to show you this little movie that someone took at the top of a ski hill where it was windy and was blowing little ice crystals into the air. And this is the movie they took. And you'll notice that there's the sun and there's rings around the sun. Okay, and the ring actually has a little kind of rainbow to it. This is an optical effect that you get when sunlight passes through ice crystals. It makes a ring shape around the sun. Well, this happens when the sun shines through cirrostratus clouds. So here's an example of a cirrostratus cloud, and there's the sun. In this case it's fuzzy, but here's the key. The ring. The ring tells you that the sun is shining through a layer of ice crystals. And that's the hint that you have a cirrostratus cloud. Here's another one. So the sun's off here, but there's that ring right there. And you also see there's a lot of texture in some of these pictures. This one, here's our ring. You'll notice also that if it's a perfectly formed ring, it actually has a little bit of rainbow colors in it. And the ring can also form around the moon. So this is the moon, and here you can even make out a little bit of the rainbow colors. You can actually see stars through this. That's how thin this cloud is, right? It's a very, very, very thin layer of ice crystals. And we don't have time to go into it here, but in many parts of the world, if you see a ring around the sun or a ring around the moon, that tells you that you're going to have precipitation in about 24 hours. That has to do with warm fronts and the types of clouds that it produces. Okay, so far we have covered the cumuliform clouds, the stratiform clouds, and there's only one shape left, and that's the cirriform clouds. Now with cirriform clouds, instead of the low, middle, and high varieties, there's only one type. It's high only, and that type is called cirrus. So cirrus clouds are these wispy, curly, hairy. What they are is they are little strings of ice crystals way up in the upper part of the atmosphere. And they form all kinds of interesting patterns. So you can have, for example, here we have some serocumulus over here, but there's the cirrus, right? These hairy looking things here. Here we have cirrus all throughout the sky. We got some cumulus down there, but everything else over here, that's all cirrus clouds. Here's some cirrus clouds that are kind of crisscrossing each other at different angles. Here's some where there's a bunch of parallel lines next to each other. Sometimes that's called a herringbone pattern. Here we have masses of cirrus clouds that look like solid gray. So you can see the hairy part near the edges, that's ice. But even if it's completely solid gray color, that's still cirrus clouds. Cirrus clouds can be straight, they can be hooked, they can leave little trails behind, they can crisscross each other. There's all kinds of varieties of cirrus clouds, but they're all high clouds entirely made of ice crystals. So we just went over the original 10 cloud types that Luke Howard described in 1802 in his classification system. So we've got 3 high clouds, we've got 2 medium clouds, we've got 4 low clouds, and we've got this one that goes over multiple heights. I'm going to give you 4 more clouds that don't quite fit well in his classification system, but they're clouds that you will see here in New Mexico quite a bit. And the first one occurs when we have wind blowing over a mountain. We have a lot of wind, we have a lot of mountains, and so we get a lot of these types of clouds. And what's happening here is the wind is forcing air up over the mountain, and when air goes up, it expands and it cools, and if it's cooled enough, it reaches this condensation point and forms a cloud. This cloud is like a little hat on top of the mountain that's kind of disc-shaped. We call that a lenticular cloud. Now what will often happen is lenticular clouds will form when air goes over a mountain, and they don't actually have to touch the top of the mountain. So here we have stacks of these disks up here. Down below we've got cumulus clouds forming, but up here we have stacks of these lenticular clouds that are forming over the sandias. These are all lenticular clouds. Now, one thing that will happen is that if we have a mountain and we have wind and it pushes up over the mountain like this, and we'll get a lenticular shaped cloud, say up here, right? Okay, but air is compressible and it's bouncy. So what happens is the air goes up over the mountain and it comes down and it compresses and then it goes back up again. And then it makes another hump like this and it bounces again. And it can do this many times actually. And at the top of each one of these humps, it'll form another disc. So what you'll get is you'll get several of these discs, not just one over the mountain, but they can be quite a ways away from the mountain. Those are all lenticular clouds. So here's, for example, a lenticular cloud that's forming away from a mountain. So there's some wave up in the atmosphere here, and at the top of the wave we're forming this lenticular cloud. So this is Mount Shasta in California, and there's a north wind blowing, air is moving over the mountain producing this little hat. But then the air is bouncing in the atmosphere, and you can see these little lenticular clouds sitting out here. They are a result of the air bouncing after it goes over the mountain. Sometimes they'll occur in stacks. This is Mount Rainier. There's a whole stack of lenticular clouds on top of it. Here's an isolated lenticular cloud. This is over UNM. And do you notice that some of these look like UFOs? So this is not my picture, but you can find lots of these pictures online where the lenticular clouds in fact look like flying saucers. And I don't know if this surprises you or not, but there's a large number of 911 calls that occur each year for people reporting UFOs when they are seeing lenticular clouds. So like these, this is another picture that's not mine, but again, those look like flying saucers, right? I mean, look at that one, right? It's like the mothership has arrived. Here's one from National Geographic. Here's a little zebra. This picture was taken right before it was abducted. So we talked about cumulonimbus clouds, and we said that these are, we call them thunderstorms usually. There are two clouds that will grow on the cumulonimbus cloud itself. So one of them happens when you have cold air that sinks down from the cumulonimbus cloud, and it makes these droopy clouds below it. And we call these mammatus, and they often occur either right before or right after it's about to rain. So here, these blobs coming down, these are mammatus. So each one of those blobs is a pool of cool air that's sinking down from the cumulonimbus cloud. So the cumulonimbus cloud is above us here in these movies. So these are all mammatus here. Here's some more. You can see here they come down, cold air drooping down out of the cloud, forming these little bulbous features at the bottom of the cloud. So those are mammatus. You see these a lot in New Mexico. And around here, usually what this means is the cumulonimbus cloud is essentially dying, and a lot of this cold air is kind of falling down out of the cloud. Sometimes they're less dramatic. So here's an anvil coming towards us, and you see these little bulges. Those are mammatus coming down out of the anvil. These are some of the best defined mammatus that I've ever seen in New Mexico. They usually don't look quite this spectacular. If the sun angle is low, that'll make them look even more spectacular. So here's some mammatus. Each one of these blobs is cold air sinking down out of a dying cumulonimbus. Now, there is another type of cloud that can form on a cumulonimbus. So we said that these things grow vertically. If the conditions are right, they will grow very fast. You can have a cumulonimbus cloud grow from nothing to thunderstorm in like 15 minutes if the conditions are right. If they're growing really fast, this column of cloud is rising so fast that it has to push the air above it out of the way. And what'll happen is this layer of air right in front, it can't get out of the way fast enough, and it's uplifted, and the whole thing turns into a little disk of a cloud. It's a temporary disk called pileus. And here's a movie we saw earlier. I was talking about the anvil, but I'm going to zoom in over here. Now watch what happens over here. There's pileus. There's one. There's one. There's another one. Those little disks of fuzz are little temporary clouds of ice crystals, and they're only there for a few minutes. So if you see an actively building cumulonimbus in the summer, you'll see them. So let's watch. There was one right here that just happened. Now let's watch over here. You'll see another one. So right in here, starting to get fuzzy. There it is, right there. And then it's gone, right? So these are very temporary features. Finally, the last feature isn't really a cloud as much as it is a process, but a lot of times it is so dry in New Mexico that when rain falls out of a cloud, it evaporates on the way to the ground. It never hits the ground. This is called virga. So virga isn't really a cloud type, but we see it so much, I thought I'd throw this in here. Especially in the spring, when we have very dry air, we'll sometimes get a cumulonimbus, a thunderstorm, and the rain falls out of the cloud, but it evaporates before it hits the ground. Now, as a side note, whenever you have evaporating precipitation below the cloud, that is causing the air down here to become colder. So evaporating water cools the air. So this air below here is becoming cold and dense, and it's sinking fast. And below here, it's actually very windy. So if you're standing below virga, you usually get hit by a blast of cooler air from this. So that's everything you need to get started cloud watching. We've got the 10 original cloud types plus 4 extras. In New Mexico, we typically see all of these clouds in the summer except for cirrostratus, altostratus, and nimbostratus. For those, you need to wait until the winter, and even then, you might see nimbostratus maybe once a year, if that sometimes. If you want to practice your clouds, if you go to the Bradbury Science Museum's webpage, we have a PDF of cloud flashcards. These are pictures of clouds for you to practice your identification with answers. I'm Mel Strong. Thanks for watching.